Okay, we're moving into what's called triangle congruence. Go back to when we were talking about the word congruence. You have used it as a synonym for equal, right? If two things were congruent, it meant that they were equal. Okay, now I need you to think about it in terms of a picture. If two shapes are congruent, they're equal, meaning they are identical. They're carbon copies. They're exact copies of each other. You with me? They may have different names, but the angle measures are the same, the line lengths, the side lengths are the same, the overall picture is the same. It could be turned in different direction, but they're the exact same. Okay, so what we're getting into is, when I give you two shapes, if I ask you to tell me, are they exact copies of each other? Are they congruent? You would have to go around and check every single side, and you'd have to go around and check every single angle, right? Does that make sense? Okay. We're going to look at just triangles. So if I give you two triangles, you would have to check how many pairs of sides to see if they're equal. You would have to check, if I give you, all right, I know y'all aren't catching what I'm saying because you should be able to answer this. If I give you two triangles and I ask you to tell me if they are congruent, you're going to have to check how many pairs of sides. What? 3 pairs of sides. How many sides does a triangle have? 3. Let me ask the question again so that y'all can feel a little bit more confident about your answer. If I give you two triangles and I tell you to prove that they are congruent, you're going to have to go around and check how many pairs of sides. How many? You're going to have to go around and check 3 pairs of sides, right? Then you'd have to go around and check how many pairs of angles. 3. You have to know all 3 angles. Come over here and check them. Right? That's a lot of work just to be able to say 2 triangles are congruent. Go to your little green cheat sheet. You get that phone out, it's mine. Go to your little green cheat sheet. These are 5 shortcuts for proving triangles are congruent without having to check all 3 pairs of sides, all 3 pairs of angles. Right? That's 6 sides, 6 angles. That's checking 12 things the long way, right? Look at your green cheat sheet. Those are shortcuts. Look at how many there are. There's 5 of them. The very first one says, well, just go through and check all 3 sides. Because in terms of spatial awareness, if all 3 sides measure the exact same on all 3 on the other one, then the angles have to follow suit. So there's a shortcut. So instead of checking all 12 items, we could just check the 3 sides, and then if they match, then we're done. Then the second one is check 2 sides and the angle in between. You see the second one on your green cheat sheet? This is where everybody's eyes should be looking. Side angle side. The third one is check what? What's ASA stand for? Check angle, side angle, which means you're checking 2 angles and the side in between. The fourth one says check what? You got to be careful there. Not angle, side, side, but angle, angle, side, right? And then the last one says, well, if it's a right triangle, just check the hypotenuse and one of the legs. Okay? So this little green cheat sheet is supposed to help you. I would keep it out and keep it handy We did label it page 50. Now I need you to go to page 51, where we are actually learning what each of those shortcuts means, okay? Looking at the top, we start with SSS. I need you to fill in, and you don't have to write necessarily all of this, the definition, but I absolutely expect you, I absolutely expect you to write that that stands for side, side, side. So what if I throw two triangles at you, and you're trying to determine if they're congruent, and let's say they have certain marks on them. Congruent marks, right? We're going to go through two scenarios for every one of these. The first scenario, you're going to see a pattern here. The first scenario is where they're disconnected. Then another word for that is disjoint. Disconnected, not touching. You with me? Look at this. Wrap your mind around this. They are not touching. These are the easiest types of problems because you run with exactly what you see. Now, your paper's already marked, I think, right? Your paper already has markings? Okay. So I'm just making them appear as I'm talking about them. So when you have disconnected triangles, it's the easiest type of problem because there's no hidden secrets, there's nothing extra. You just go off of the picture. So if I threw these two triangles at you with these marks on them, and I said, do you have enough info to say that these triangles are congruent? Your answer would be yes, because all three sides correspond to all three sides. Notice you have congruent. You have congruent, congruent. Here, equal, equal, and then here, equal, equal. With me? So you could say those triangles are congruent to each other because of the side, side, side shortcut. Yes? All right, not bad. Now, what if they're connected? Once again, like I said, there's a theme here. The first one's easy. The second one has a small trick. I need you to start training your brain to look for the trick. It will make life easier, okay? The trick is never marked. You have to remember to mark it. Look at example 2. They're touching. All right? That means there's something hidden here. Do you notice this side right here is shared? So imagine if these were two tiles, like, you know, those little algebra tiles. Do you remember those? Or blocks or shapes. But imagine I pulled them apart. You don't have to draw this. But this would go here, and then this, and I'm fixing to move. I know I'm blocking the people behind me. That would go there. And do you notice that this right here, that side, would have to be drawn twice? Do you see that visual? If I pull them apart, that shared side is going to have to be drawn twice. So can we say that the highlighted green side in the top triangle has to measure the same as the highlighted green triangle in the bottom triangle? As the highlighted green side in the bottom triangle? Why would they measure the same? Because it is the same side, right? Are y'all with me? Yeah. It was a shared side that gets duplicated as I pull them apart. All right, so here's what I need you to actually put on your paper. One, if you have a highlighter, it would help to highlight the shared side. If you don't have a highlighter, take your pencil and make it thicker, bold it, kind of like I've done right here. Ashley, will you quit with that and get with me? Make it bold. And then I want you to take your pencil, draw an arrow, and I want you to write shared side. Write shared side. So because this right here is a shared side, it would be congruent. This is going to sound weird when I say this. It would be congruent to itself because it gets duplicated if I stretch the triangles out. So I'm going to write a congruent mark to show it's congruent to itself. Notice I had to put 3 tick marks. I didn't want to put 1 because then that would imply it's congruent to these sides over here, right? Y'all have to look up here in order to understand this. I didn't want to put 2 because that would imply it's equal to those sides, and we don't know that. So I put 3 to say, hey, it's equal to itself because it's shared. Yes? Okay. So that's an example of where side, side, side could be used. And it's tricky because when you first started the problem, you only had the 2 sides, but you actually have all 3 because of the shared side. Yes? Go to the second one. SAS. What does that stand for? Side, angle, side. Side, angle, side. Okay, let's look at the first example, the easier ones because they're disconnected. There's nothing secret here. You will notice that we have congruent marks on this side with the 1. Then we have an angle. I actually want you to take your pencil and I want you to exaggerate the congruent arc on that angle. I want you to exaggerate it beyond the lines of the triangle. There's a reason for this. Then we have another side that's congruent. Now, with these shortcuts, order matters. So if the name of the shortcut is side, angle, side, this means as you are tracing around the triangle, you hit a congruent side, immediately a congruent angle, and then immediately a congruent side. Which means, what's in the middle? An angle between 2 congruent sides. Look at the picture. If you extend the angle that's congruent, notice it's touching, I'm going to change to a highlighter. Notice it's touching, let me change the width of the highlighter. Notice that that congruent angle is touching that side and that side. Do you see it? Go to the other triangle, find the congruent angle, and then look at the sides it's touching. Do the sides it's touching correspond and match? Yes. Then it's side, angle, side. It's a side, angle, side shortcut because you look right here. This is a side. I'm tracing. That's an angle, and that's a side. Then you have to come over here and double check, make sure it's the same. You got a side that's congruent, an angle that's congruent, and a side that's congruent. See that? All right, now let's go to the tricky one. The tricky one is when they're touching, something's not marked, right? So right here, if I look at this, I see a congruent side, another congruent side, but they're touching, the pictures are, so there's something not marked. This is like a month old. Do you notice what's not marked? Yes. Do y'all remember learning that anytime 2 lines cross, you get vertical angles?
Yeah.
And we had pictures of this from previous problems.
Yeah.
There is a secret vertical angle right here and here. I want you to take your pencil and draw an arrow to both and just write the word vertical. And I'm going to abbreviate angles by drawing the angle symbol and putting an S. So we have vertical angles there. Colt, stay with me. We've got vertical angles. So now do we have enough information to say the triangles are congruent? Well, it helps if you look at your sides to make sure that that angle is in between. There's my two sides, is the angle that's congruent in between those two congruent sides, on both. Yes. So, yes, they are congruent by side angle side shortcut. Okay, now let's totally flip it. Now we're going to do angle side angle, right? Okay, so ASA stands for angle side angle. ASA stands for angle side angle. First example, easiest type when they're not touching, because it is what it is, right? There's nothing extra. Okay, so looking at it, I definitely see that I have two angles and I have a side. Then I have two angles and a side. Order matters. If you're going to use ASA, then the side has to be between the two angles. Do you see that? As in terms of the name of the shortcut? So coming over here, this is where it helps either take a highlighter or take your pencil. Find the side that's congruent and bold it. Bold the side that's congruent. And then ask yourself, are the congruent angles flanking? Y'all know what flank means? Meaning it's on both sides, right? Like coming on both sides, up beside it. So the two sides that are congruent, do the angles touch it? Here they do. What about over here? Yes. So then this is enough information to say we have an angle, a side, and an angle. And here we have an angle, a side, and an angle. So they are congruent by ASA. Okay, now let's practice the sneaky one. We got a pair of triangles. If I said, hey, are these triangles congruent? You would look at it at first and you'd say, well, I don't know, there's not enough information, but they're touching, so that means there's something hidden. We have to mark what's hidden. What is it? Again, we got vertical angles. You're going to notice the pattern here. It's either shared side or vertical angles every time. All right, so I'm going to draw an arrow and I'm going to make a note. I want you to write this. It's going to train your brain to find the vertical angles. When I write that they're congruent, do I want to draw a single arc? No, I need to draw two, right? Because we don't know that it's actually equal to that other angle that has the single arc. And then now we're going to check the shortcut. We're looking for ASA. Highlight the one that's in the middle, the side, and then confirm it's touching both pairs of angles. And it is. So yes, they're congruent by angle, side angle, shortcut. All right, we have another shortcut that works. Notice the difference. What happened to the side that's congruent? It's no longer flanked between two congruent angles. Now it comes after them, right? AAS stands for angle, angle, side. We no longer have the congruent side touching the two congruent angles in between. Now it is on the end of it, which means this is why highlighting or taking your pencil and darkening that congruent side is so helpful. If I darken this congruent side here and this one here, I notice it's only touching one of the congruent angles, right? That would tell me that it's not ASA because it's on the outside, right? So it's coming after it, so it's AAS. They're totally different. If you notice right here, see how the congruent side here is touching the two congruent angles, but the congruent side here is only touching one of them. We'll look at the S in the position of the word. Here it's touching both A's. Here it's only touching one of them. You see that? All right. So the two disjoint, you would check it off. You would look at the triangle and you'd say to yourself, okay, well, there's a congruent side, there's a congruent angle, and there's a congruent angle. And then you would look at it in the order as you would be tracing the triangle. Well, we don't have an SAA, and you don't jump around as you're tracing it. We have an AAS. And you have to come over here and verify it's the same. This is the same thing, AAS. Now, what if they were connected? What's not marked here? Once again, vertical angles. Mark it and write it. And then I'm going to highlight the congruent side to show you that it's only touching one of the angles that are congruent, which is what makes it AAS. All right, we have one more, and this one is the special case scenario, because this works with only right triangles. So what I'm going to show you, I want you to write everything down. HL stands for hypotenuse leg, and I want you, let's see, I want you to absolutely write what it says right here, and I want you to highlight the word right triangles, or I want you to write it in all caps if you don't have a highlighter. But it is only with right triangles, which means one of the angles has to measure what? 90 degrees. This only works with right triangles. Shortcut. Now the good news is, I know some of you are probably already thinking that you don't understand this. I have no intentions of teaching anything new tomorrow because this is really important, so we're going to practice it today and practice it tomorrow. And we're going to have a quiz over, can you recognize which shortcut would be used? Okay. I don't know about a test. I'll let you know. All right, now that you've written it down, let's look at the two scenarios. Scenario one is when it's easy. Everything that is presented in front of you is all you have to work with because they are disconnected. You need to first verify you have right triangles, which means what angle is in there? A 90-degree angle. Okay, then you also need to verify that the hypotenuse is congruent. You need to remember where the hypotenuse is. I want you, and this is leading directly into our next unit, I want you to train yourself to take your pencil, find the right angle, draw an arrow from the right angle to the side farthest away, opposite of it. That is the hypotenuse, every time. Then I want you to label it HYP. Then come over here and do it again. I want you to start training yourself to draw an arrow to the hypotenuse because it's going to help you when we hit the next unit. Okay? So in this particular case, I have two right triangles. The hypotenuse is congruent. Do you remember what makes up the leg in a right triangle? It's the two remaining sides. There's two legs in every right triangle. It's the two sides that form the right angle. Think of it as the L, legs. see what they did there? Think of it as the two sides that form the L, the right angle of the triangle. Those are legs. So this is a leg here. I'm going to put a check. This is a leg here. So because I have a congruent hypotenuse and a congruent leg, and they are right triangles, then I could say that the two triangles are carbon copies, completely congruent by the HL shortcut. Okay? Now, what if they're connected? It's a little sneakier because when you first look at it, you probably think there is not enough info here, right? But there actually is enough info. One, you know that the two triangles are what type? We've got right triangles. Two, you've got a pair of congruent legs. And then what's missing? What's the hidden part that needs to be marked? The hypotenuse is right here. Notice that this is a shared side. I want you to write this. That is a shared side. If I took those two triangles and I pulled them apart, that side would get drawn twice, right? Duplicated. So you would make a note to yourself, this is equal to itself, because it's going to get copied if I was to separate it. And it's the hypotenuse. Look at this. Here's the right angle. Go to the side opposite. Here's the right angle. Go to the side opposite. So this is the hypotenuse for both of them. So they are congruent triangles by the HL shortcut. Okay? All right. Now we have a couple of disclaimers. It's kind of like at the end of a commercial for some type of medicine, and then all of a sudden the guy starts talking really fast to let you know all of the side effects that you're going to experience, or the people who don't need to take the medicine. We have some disclaimers here. First of all, when using the hypotenuse leg, make sure to remember to check if it's a right triangle. HL only works in right triangles. The way to remember that, by the way, this is how I remember it. If you look at your green cheat sheet, you can see this better. Look at all of the acronyms for the 5 shortcuts. Look at all of them. You've got SSS, SAS, ASA, AAS, then you have HL. You with me? Do you notice only one of those shortcuts has right angles in all of the letters in the acronym? Let me say it again. Do you notice only one shortcut First of all, do you notice how it's every single permutation without cussing? You notice how only one shortcut has right angles in every letter that's in the acronym? That would be HL. You got a right angle, right angle, right angle, right angle, right angle.
What about angle side side?
Okay, I'm not there yet. So that's how you know that this one has to have right angles. Okay? That's the first disclaimer. The second disclaimer says there is no AA or AAA postulate for congruence. We have one for similarity, preview of what's to come, but we don't have one for congruence. What do you notice about every single shortcut? What letter is in every shortcut? Now, you might say, well, it's not in HL. Well, HL is still referring to the sides, right? It's just they're calling them H for hypotenuse, L for leg. So what letter's in every shortcut? S. So what has to be marked in every example? A pair of sides. At least one pair of sides. So notice disclaimer number 2 says there's no AA or AAA postulate, meaning there's no batteries. With me? There's no AA batteries, no AAA batteries. So I want you on your paper right here in the space, I want you to make a note. Notice, that's an N. Notice there is always at least one pair of congruent sides. There's always at least one pair of congruent sides every time. Otherwise, the answer is no. You can't prove the triangles are congruent. There's always at least one pair of congruent sides. And last example addresses your question, Wally. No, we are not cussing in here. There is no cussing. So no, angle side side, as an acronym, is not acceptable. So don't be an ass and try to use that shortcut because it doesn't exist. Okay?
Does it exist? It just doesn't exist in here.
No, it's not enough to prove it. It's actually, there's a legitimate reason why. If you had an angle side side marked, right, it's not enough to show that the two triangles are congruent. That shortcut doesn't work. Yeah. So basically, don't try to cuss in here and you should be fine. Okay? What? Even if you write where? Oh no, that's an O. That's why there's no dot. I was writing fast. Okay, so now let's practice. Let's practice. Go to the bottom. The first four are saying determine if they are congruent. So right here it says determine if they are congruent. Meaning, do you have enough information? Well, if the triangles are disconnected, then you just run with what it tells you. But if they're touching, that means there's something hidden that's not marked, and you have to mark it. Well, because that's usually the case with all of ours, these are all touching, so we have to mark something. So the number one, what is not marked that needs to be?
Vertical angles.
There's a pair of vertical angles right here. I want you to make a note. Vertical angles. I want to see that on your paper because it's going to help you when we get to the next unit. So I can mark these congruent. I need to put new marks though, right? I don't need to copy a single. And then now you're going to trace around the triangle and look at what, like take inventory on what's marked. All right? Yes, very good. So I have a side, I have an angle, and then I have an angle. Now come over here. I'm running out of room. I've got an angle, and a side. This is the biggest problem. These people will say, okay, so it's either angle, side, angle, or it's angle, angle, side. Look at the difference in the acronym, in the shortcut. If it's ASA, then the congruent side has to be touching the two congruent angles. If it's AAS, then the congruent side is only touching one congruent angle. Then go to your picture. What's the scenario? It's only touching one of them. There's the side, it's touching that one. This one, look at the gap. This one's all the way over here. It's not touching it. So that means it is not this one. It is AAS. You see it? Really helps if you highlight the congruent side because then you can see that it is touching or is not touching. Okay? All right, the next one. What's not marked? Once again, we got vertical angles right here. All right, so I'm going to mark it. Now, do I want to put a double? No, I want to put a single. Nope. Is that you?
Yeah. Right.
Now, take a second, look at it. Remember, the big question is, do we have enough by our shortcuts to say that those are congruent triangles? Look at your shortcuts, look at the picture, look at what's marked, take inventory. please put your pencil on the pair of congruent sides. Would you put your pencil on the sides that are congruent on example 2? Are they marked? No, you can't mark them just because you want to. You're going off of what they give you or the sneaky hidden part.
But they have to be.
No, they could be off by a tenth.
But again, because they're both 90 degrees and the angles are vertical.
No, they can be similar.
You don't really know.
That's the whole point, is you don't know. So you're going off of what you have in front of you. So the answer here would be technically not enough information, or we would say, no, we can't conclude they're congruent. Does that make sense? So this would be not enough info. Also remember, we said you have to have at least one pair of congruent sides. There's no AAA or AA batteries. All right, number 3, what is not marked?
That shared side.
This shared side right here would be equal to itself. I'm going to put a single mark since the other ones are double. I'm going to make a note that this is shared. And then now I'm going to ask myself, do I have enough info by my 5 shortcuts? So go around the picture. So this is a pair of sides, this is an angle, this is a side, this is an angle, and this is a side, right? So what's the shortcut? SAS. Do you notice how if you focus on just one triangle, you see SAS. Now come to the other one and make sure it's the same. SAS. So the answer is yes, and it's by the side angle side shortcut. All right, number 4, what's not marked? There's a shared side right here. Make a note. Like I said, you're going to see a pattern. You're going to see a pattern. Then you're going to look at the picture. Now you might think it's donkey. It's cussing. It's ASS, but we don't have that. What? It is HL. What type of triangles are these? Okay, so let's make a note. We've got right triangles. Is the hypotenuse congruent? That would be the side opposite of the right angle. Do we have that marked congruent? Yes, on both of them. I'll put a check mark. We have right triangles. We have the hypotenuse congruent. Do we have one pair of legs congruent? Yes, so it is HL. Okay, we're gonna jump around. I want to just today practice with just being able to say yes or no. They're congruent by the shortcut. I don't want to do the next part because the next part takes it a step further. We will save that. We'll pick up on that tomorrow. So keep this paper out. I'm fixing to tell you where your digital assignment is. When you go into Delta Math, you're going to see that there are 15 questions. The first 10 are just say yes or no. They're congruent, yes. They're not congruent, no. The last 5 questions are first, yes or no. And if the answer is no, then the problem's done. If the answer is yes, they want you to be specific and to tell me, okay, so what's the congruent side, what's the congruent angle, Or what's the other congruent side? So let me show you. So like number 1, you would have this picture here, and it would simply say the 2 triangles are related by, and then you have 2 drop-down menus. The first drop-down menu, if you look at it, is all of the possible scenarios. Notice one scenario is one we talked about never working. It's the battery one. You see AAA right here? AAA? That means if the picture is marked with all 3 angles congruent, you would select that it's AAA, but then you would say, oh, that means you cannot prove it congruent. That's a no-no. In this particular case, what do I have? Well, let me zoom in. They're disjoint, which means this is easier, right? What do I have? A pair of, what am I pointing to? Sides, an angle, and another side. So you would say, right here, that it's congruent by side, angle, side, and that would mean they can be proven congruent, because that's one of your 5 shortcuts. Does that make sense? Y'all with me? It's not posted yet, so I don't know what y'all are doing. All right, look right here. What's marked?
The 3 sides.
The 3 sides. So the drop-down menu would be SSS, and is that a yes or no that they
Yes.
can be? That's on your 5 shortcuts. I just printed. All right, so there you go. Look at that one right here. You got all 3 angles. So the first drop-down menu would be the AAA batteries. But then the second drop-down menu, you would say, you cannot prove it then, because all I know is the angles. Does that make sense? Now let's go. You got 10 of those. Let's go to this. These are drop-down menus right here. So once again, it's going to give you the picture. You're going to like that they're disconnected. I'm pretty sure they're all disconnected. We will practice them connected on paper, but I think Delta Math does them all disconnected. So right here, what do I have marked? I've got angle, side, angle marked. They want you to fill this in by that order, okay? So if you call it by angle, side, angle, then this first box you need to say, okay, what angle is equal to what angle? Look at my picture. I would say angle J is congruent to angle what over here? C. The side that's congruent, I would say side JK is congruent to side what? ZY. Then the last angle would be angle K is congruent to what? Angle Y. That's what they're looking for. And then they want you to say, okay, so the 2 triangles, you call it KLJ, or I went backwards, KJL. If I go KJL, I have to call it YZ, right? And it would be by angle, side, angle. Does that make sense? All right, let me hit post and you can start on it.